Okay, if you want to share your screen, meanwhile, welcome everyone to our webinar and also guest lecture. And this time we have Dr. Tamara Saipis from UnitedHealthcare, and Dr. Saipis is a chief data scientist and also a advocate for modern machine learning approaches and product and technology, and a big proponent for moving companies forward on their AI maturity journey. And he has 20 years of machine learning leadership and innovation experience, envisioning and managing and deploying ML products at scale, and have a proven history of ML product portfolio modernization and improvement in performance, scope, and scalability. And Dr. Saipis has a Ph.D. in computer science with emphasis in AI ML from Vanderbilt University. And it's great to have you here. And
thank you. Thank you so much. Thank you, everybody, for joining. I'm going to share my screen. Can everybody see my screen?
Yes.
Okay, great, wonderful. All right, I'm going to leave a lot of time for questions because I think we're going to have some interesting discussion. And I just want to give you sort of a little point of view and advice on how to openly think about your career and be open to both research and industry. And I've been easily going from one to another, and it really helped me out in both having that other experience, whether I was doing research and having a little bit of industry experience and vice versa. All right, so today we're going to talk about an AI maturity model that was developed for UnitedHealthcare. AI maturity models are, you can find several ones out on the web, but this one was really tailored to what we need within the company where I work. Thank you for the introduction, Dr. Sun. So I'm going to talk about just a little intro and then talk about why it's important to have a maturity model and have a disciplined approach to how we do AI and machine learning, and then talk about different stages and just kind of maybe motivate you to think about what you can do to make sure that the work that you are doing maximizes the benefits of AI wherever you end up going after your grad school, and that it minimizes the risks. Okay, so got introduced. I think the only other thing I can add is that I've done just about anything in this domain. I have not worked in financial industry, but I have worked on financial data for healthcare. I have done anything from being consultant, hands-on building predictive models for companies, to having published research, coming up with a novel machine learning method, to submitting patent applications, to speaking, to teaching, working in a variety of domains, and currently and most recently I've been in healthcare for about 10 years. So AI, machine learning, deep learning, I'm sure you guys know all of this, but this is my little intro slide. Machine learning is a subset of AI. The easiest way I can think of telling somebody that is not as technical as the students here are is that it's the learning, it's the art of learning from the experience of your data, right? And that kind of sits well with some of the industry audience. Deep learning, of course, is just a subset, just another of the methods in the palette of machine learning methods. And then, we often get the term data scientist and data science, and basically it's an application of AI, most specifically and kind of commonly machine learning, to solving business problems and really coming up with the insights for the business problems. All right, so why is AI maturity important? Well, we are experiencing the era of, we're within this AI transformation era. It's everywhere. A lot of investment, a lot of excitement. This was created before ChatGPT. Even back then, we had a lot of excitement. But really, AI is driving digital transformation and creating significant value for businesses and companies. It's expected that $13 trillion will be added to the global economy because of AI. And so there is no wonder that, according to this survey done by IBM, 84% of the executives are really expecting to see steady increase, of organizational focus on AI and trying to really find that insight in the data to make companies do what they do better, faster, and more accurately. So AI is currently being used as competitive advantage. Companies that don't use it will soon be left behind, as we know. It really increases what the business value can be for that organization, but only when done right. So if you think of different maturity levels and revenue, and just any general industry, companies that are piloting AI, they're just tinkering on the side with some POCs and whatnot, will not have as much business impact from AI as the companies that are steadily implementing, using AI. They're operating, so they're really leaning on AI, or productizing. Productizing is a term, believe it or not. It means you're optimizing AI at the product level. And I'll talk about it. It's maybe a vague concept for you guys right now in grad school, but dealing with products is a really wise way to go. If you think of your predictive model that you create, you're going to code it. It's going to be AI software down the road. And if you treat it as a product, a software product, if you're careful in, just vetting that product before it goes into production, if you're careful about, is it solving a consumer problem? If you're not just doing something for the sake of doing it, but you're actually solving a business pain point, or solving the business's consumers problem of some sort, that's going to be much more powerful to that business. So treating AI as product is really important. So companies that are piloting will obtain limited return on investment, whereas companies that are productizing will maximize what they can do with AI. So also companies that are piloting can have negative business impact, because somebody can tinker with something on the side of their desk and it could lead nowhere. So therefore it's a negative ROI, because they wasted time and money and didn't do anything with it. They could have done something else that would have been useful to the business. All right, so I'm going to show some examples, and believe it or not, I've worked in a bunch of companies. I've seen all of these everywhere I went, and there are resources out, in publications that talk about some of these common pitfalls of how AI is done. By AI, I mostly mean machine learning, right? But same old, because it's a subset of AI. So sometimes people would build a model and nobody's using it because they didn't really, they didn't have a collaboration with the business. They were not solving something that the business needs. So it's really essential to connect with the business leadership and see if that solution would be useful to the company. Dealing with imbalanced data sets, you guys are sure familiar with that. Can use certain evaluation measures for imbalanced data sets. You need to know how to do it. So that's a nice technical skill to hone right now. How do you subsample, oversample, do creative sampling? How are you able to extract information for imbalanced data sets? Super important, because imbalanced data occurs really often in real life. If you come to think of it, we usually have a small number of interesting instances in our training data, whether you're modeling, cancer, or some type of drug discovery, or if you're say in insurance fraud, right? If it's say healthcare fraud, you have maybe 1 to 3% of the instances in the training data are interesting. The rest of them are not. They're all, good claims or whatnot. But so how do you extract that information and create an adequate model to make sure that you're actually going to have a model that's useful for stopping fraud in the future. And then another thing that commonly happens is your AI, so your model is an AI product. We talked about it. If you're really truly dealing with it as a product, that means that you're going to do performance monitoring. You're going to know what your product is doing, and you're going to be having a scheduled cadence of refreshing your model. This is especially important in domains such as healthcare that are very noisy and they change a lot. So if you have a model that's stale, built on a data set from 5 years ago, it's not necessarily going to act really well in today's day and age, right? So you need to make sure that, first of all, the model is being monitored. And second of all, that you have a scheduled cadence of refreshes of your model. And if the monitoring results are showing drift or something like that, something's not happening as it's supposed to, that would trigger a sooner refresh so that you can fix that. And a refresh means you add the most recent data available, maybe append it to the historical data, maybe do a sliding window or something, and then you create a more up-to-date model. And then, you guys are not, you probably don't see this, but in industry, we see this often. There's people taking a little weekend course or just learning a little bit on the side, and now they want to build models, or they are what we call citizen data scientists. They use AutoML and think they can do things, but in fact, it's not that easy. They can create some of these common mistakes and end up in one of these common pitfalls. And it's really important to follow best practices and guidelines for anybody, even if they're an AI novice. Okay, and so why all of these examples are a problem? Because they have the potential to diminish trust in AI. And that's a really big downfall. So whether you're working in research or whether you're working in industry, continuously worrying about the quality of the work being done and making sure that you're constantly increasing the trust in AI is really important. Now, here's an example of what happened with ChatGPT. It was totally overhyped, really overpromised, and then we've seen some examples of it just, having really bad answers in a variety of situations. So doing it right, making sure the best practice and guidelines are followed is really important. So here's another example. This is from research, from the research world. So back in the COVID days, there were more than 300 inadequate COVID-19 models that were trying to detect COVID early on in the pandemic from medical images or skin scans or anything like that, where we don't actually have to swab a patient and try to run a test. There is an interesting Nature article that talks about it. And it was mostly because they had really small or biased data sets, or just didn't know how to do it right, basically how to create a solid predictive model with the data they had. My favorite was, there was a study that trained a model on, back in the early days of the pandemic, kids didn't used to get it. So they were training on positive adults skin scans and the negative examples were kids. And so their model was really good in telling the difference between children and adults skin scans. So I thought, that's just such a bad example, right, of how people can do it that's not in the right way. And again, the concern is that it has the potential to diminish trust in AI. So finally, there was a company that solved this problem. It's called Tiger Tech. I don't follow this company. I don't know what happened to that product, but they were FDA approved, and they actually had a really good predictive model that was able to sort of like similar to your Apple, iWatch or another iWatch or fitness trackers, could really tell whether the person's pulse rate and other factors were more likely to kind of identify blood clotting and therefore COVID infection. All right, so that's what the good looks like. And so finally, we come to, so how do we define AI maturity? Well, it's really mature AI is a product that's properly built, operationalized, consumed, and maintained. Consumed is important too, because sometimes people create the best predictive model there is, but they don't really understand if those input features are available at the runtime and they can't use it. So if you can consume it, if your model sits in a PowerPoint or in a someplace like that and is not being productionalized and consumed, there will be no business value to that organization, right? So it has to be productionalized, it has to be used properly and consumed. And then we talked about maintaining as well, maintenance as well. So a mature organization, AI organization, is then able to really operate at the speed of their data, because nobody is manually tinkering or processing or slicing and dicing the data. It's AI is used to extract the insight and information from data, and then use that to do whatever they do more accurately, faster, and cheaper. So creating this faster, cheaper, and more accurate operating model is the whole business benefit of utilizing AI. So if you think of companies and their maturity journey, when they first introduced AI, they probably will start with some POCs, see what that looks like, try to scale them up, and so on and so forth. But if you really think about how do we define the important founding pillars of AI maturity, there are three. First one is this organization or team ready for AI? And that means that they have people that know what to do it. They have data available, and if there is a nice data infrastructure that enables data scientists to go grab the data quickly and easily and combine them and all of that, the better. And then also, what's their development platform, this model infrastructure where they can develop it, and if they can productionalize it really easily, that's a win, right? So AI readiness is that first pillar that's necessary for having a mature organization. The second one is AI enablement. That means there is strategic investment. If there is no investment and leadership support and partnership with business, it's hard to do anything on a larger scale. There also needs to be AI strategy. So my job as a chief data scientist at UnitedHealthcare was to first and foremost create our mission and vision and strategy of getting there. And that's important, because if you don't have a plan, you're not going to be moving, you'll be being scattered. You're not going to move in the right direction, in a nice, swift, kind of streamlined way, right? So having that strategy and vision is really important. Having best practices and guidelines. All of us that are classically trained in AI and machine learning, we know the processes, but there are a lot of people that don't. So having that published, having these other enablement tools, say like mentorship or anything else that can help these people that are newer, is really important. Another thing that's essential is verification. Just like with any code, before you put in production, you would have a code review. Same with AI code, making sure the model was built properly and doesn't have any technical debt. If it, for example, if it was built on an imbalanced data set, that it uses appropriate evaluation methods, you can use accuracy for that. That was developed properly, sampled properly. So that technical verification is really important. And after that, a lot of companies these days are implementing what we call responsible use of AI verification, which is a board where we have AI experts, we have legal, compliance, and policy folks vetting that solution is going to be unbiased. And that means that it's going to be fair to any population or gender or minority. That's going to be equally and fairly treating all of the people that are using it. And that's super important, again, because of the trust in AI. that's ethically used, and all kinds of things that we vet there that are really important. So AI ethics and responsible use are really important, and a lot more companies are investing into having these boards and making sure that their AI products will not end up, you know, in a New York Times, article talking about how their AI is unfairly treating this population or that population, like it happens. And then finally, treating AI as a product. Talked about it a little bit already, and really basically answering early on who, what, where, when, how will use your model. So if you don't know that, you can't do it right. So answering those questions early on is really important to be able to properly build, operationalize, consume the model. Having that end-to-end capability of idea to production, ability to productionalize things and monitor, super important, maintain, and then also if we can have component reuse, even better, because we can say in healthcare, we have some ways of condensing the information on a medical claim, right? Whether it's professional or facility claim, in such a way that we extract information better. Well, we can share that among different models. This claim embedding, as we call it, input features are super useful. Why not? We don't have to reinvent them every time we build a model. Why don't we share some of these important input features, or how we deal with, say, imbalanced data sets for this domain, or so on and so forth. Really important to getting that return on investment and really winning with AI quicker and faster and better. All right, so so when these maturity stages, then the higher you are, the higher the quality of AI and the higher the enterprise impact, because you'll be doing more with AI in a better way. If you think of the AI maturity model and those three pillars, I transported and transposed the matrix basically. So now those pillars are rows, because I wanted to kind of dissect and show you that piloting, implementing, operating, and productizing really have different values for each of these three pillars. So piloting, usually you have low readiness, whereas productizing companies have optimal readiness. They have experts working on this. It's easy to create models, easy to access data. Enablement also goes from weak to optimal. For people that are productizing, they have strategy, they have best practice and guidelines, they monitor their AI products, they maintain them properly. And then finally, AI as product, that pillar. For piloting companies, they're all pilots or POCs, proof of concept studies, or something tiny, right? Whereas productizing companies deal with AI products, not projects or ad hoc projects, with products. And then, of course, enterprise impact is profound when you're doing it right and really maximizing and in productizing what you do with AI. So that's it in gist. I'm just going to go briefly talk about these different readiness levels. I'm not going to bore you with this, but readiness levels go from weak talent pool, no model infrastructure, hard to build a model, productionalize it, to having strong talent and enabling model platform where you can click and productionalize your model, and having a strong AI community. Enablement, from no strategy, no best practices, to enterprise level strategy and established governance and best practices. So no model goes into production without vetting. High trust in AI, lots of innovation, things like that. That's the optimal AI enablement pillar status. And then finally, the productivity, we already talked about it. From pilots, not really knowing who's going to use your model or how or where, if it's going to be useful to the business, to optimal is really understand these 5 W's: who, what, where, when, how will use your model. The why is in the benefit, in the problem definition. Key performance indicators are identified and monitored and measured. Maintenance is triggered if some of the KPIs are low. There is inventory search, so you can reuse maybe a model or model concept, or say that claim embedding input feature to other models. Just kind of do it in a smart way, basically, you get to that optimal level of AI product capability. So where are most teams? All over the place. Anywhere I've been, all over the place, from piloting to productizing, even the negative. We've seen examples of negative too, where people are tinkering and it's not useful and they just wasted time and money, basically, right? So knowing who's going to use it, where, when, and which part of the process, whether you have those input features at runtime, is it solving a business problem? All of those things are really important. Your model cannot live in a PowerPoint if you want to, wreak business value with it, if you want to gain business value with it. So really important to have it productionalized and utilized in such a way that it solves the actual business problems and pain points. So what can you do? So this is, you're in grad school, when you go get a job, say it's industry or research, just make sure it's useful. If it's a research predictive model and you're solving a generic problem for a domain and you're creating a publication, right? That's great. But that model can then be taken from a research model to an actual application. You can actually spin a company to go solve a business problem and really create value that way, right? Super important. So thinking about how is it going to be used, where, know your data, really understand the data, where it came from. All of data is biased. Make sure that it's not really skewing what you're doing. Make sure you mitigate the bias once you detect it. Understand if it's unbalanced, how are you balancing it? Are you using, SMOT or synthetic data of other type? Or are you rebalancing it? Knowing that if you rebalance your model and then your data set and then create a model, and so let's say you rebalanced it to 50-50, say it's a binary problem, you had 3% interesting class, 97% uninteresting class. You use some creative balancing techniques and you got it to 50-50. What do you need to do after that? You need to go back to the original population, right? Because your model, when you put it in prod, you don't want it to predict 50% of everything is going to be fraud, right? Because that's not the original population's composition. Make sure you go back to the original statistics of your population to be having an adequate model in use, right? Really important things like that. Make sure you're evaluating your models properly. I often find, this is a good piece of advice, if I'm working in a new domain I don't know much about, I go to the SMEs, subject matter experts, and ask them for their hypotheses. What's your hypothesis? What do you think is important here? How do I get, my oligonucleotides to work or bind or whatever? They give me their hypotheses and I create input features. I swear, I've done that many times and it was the best advice that I can give you of what makes it really solve that problem. Like how do you create these input features that are useful to get that adequate model at the end? Employ best practices, technical and bias verification, really important in anything you do. And then have that maintenance plan. And no matter where you are, what you're doing, continue learning. This is an ever-changing field, and we learn something every day. It's a domain that's just continuously, moving forward. There are new advancements every day. Just continue to learn. All right. So on that note, when we first created this, my team was about implementing. On average, there are teams that were at productizing, teams that were piloting. Within less than a year, we jumped to the operating level. And it's because we invested into strategic, we got a leadership to support us, and we had strategic investment, we had strategy, maturity model, we hired good talent, had our verification and mentorship, best practices in place. We have a coalition where we collaborate, share, co-create together. Just all of these things made us operate at a higher maturity level. And then finally, things to remember. Why are we talking about maturity? Why is there a maturity model all of that, because how AI is done is directly related to the return on investment, to the business value it's going to bring you. It's also directly related to the level of trust in AI, right? And we're continuously thinking about it. So maturity is readiness plus enablement plus product, those three pillars. If you work on each of them, wherever you end up going after grad school, that's going to be important to get to the next stage of the maturity level. And this is sort of my business point of view advice. Wherever you end up, assess where they are. Excuse me. You know, work on those things. Get those kind of founding parts of each of the pillars. Improve them. Do your part, and then that's going to help you continue to move forward on your AI maturity level to the productizing.